In this tutorial, we will talk about how PID controller works on MPLAB to control the position of the motor with Huber Plus motor driver. First of all, click the first link below this video to download the sample code. If you open up the folder that you downloaded, you will see 4 C code files, and then you need to create a project file. If the project file is successfully created, you will see 3 source files and 1 header file on the left-hand side. Before we look at the sample code, let's talk about the PID controller first. PID controller is the most widely used feedback controller in industrial control systems. We can easily find the controller operated by the PID feedback control system around us. For example, thermostat and microwave keep their desired temperature that the user set up during operation. The PID controller algorithm involves 3 different constant parameters: the proportional, the integral, and derivative values, denoted P, I, and D respectively. Then let's talk about the proportional term. It depends on the current error. It makes the current error signal multiply with a gain Kp. The result will be the output signal. So the mathematical equation will be expressed as Kp times E. The integral term depends on the accumulation of past errors, and it makes the current error signal value and duration multiplied with a gain Ki. The result will be the output signal. So the output signal will be mathematically expressed as Ki integral from 0 to t e of tau d tau. The derivative term depends on a prediction of future errors based on current rate of change, and it makes the rate of change of the error signal multiply with a gain Kd. The result will be the output signal value. So the output signal will be Kd times derivative E of tau. PID controller can be schematically expressed as the following picture. For the first step, your desired output, which is the target value, needs to be put in the control system. Then the difference between the desired output and the measured value from the sensor, which is an error, will be calculated with the equations of 3 separate constant parameters P, I, and D. The solutions from each equation will be added together and sent to the operator, which is a motor in this tutorial. The most important step in PID control system is the feedback step. It keeps the output values to be close to the target value. Now, let's look at how the PID controller works on MPLAB code. In this sample code, 1 rotation of the motor is same with 4000 of the encoder value. So for example, if we want to rotate the motor in 90 degrees, the target value should be 1000. The name of the encoder value used in PID controller is PID encoder. Here are the 3 PID control gains. You adjust the gain values to decrease the error percentage. Error is the difference between the target value and the current encoder value. Error sum is the accumulation of the past errors, and the previous error is saved as pre-error for the derivative term. The register controlling motor direction is set up on the pin number B14, which is channel 1 PWM high signal, which is called PWM1 CON1 bits dot PEN1H. If the register is 0, the motor will rotate in counterclockwise, and if the register value is 1, the motor will rotate in clockwise. By using this register, we can control the direction of the motor depending on the sign of the error value. If the error is less than 0, it will rotate in counterclockwise, and if the error is greater than 0, it will rotate in clockwise. Here are 3 if loop statements. The first 2 if loop statements are written so that the duty cycle doesn't go over 10. But if you want to rotate the motor faster, you can increase the number. And the last if loop statement is written to slow down the motor when it gets close to the target value. Thank you for watching.